So today let us start with the class. In this class, I'm discussing here dual slope integrating type DVM and successive approximation type DVM. So coming to dual slope integrating type DVM, this is the most popular method of analog to digital conversion. In the ramp techniques, the noise can cause large errors, but in dual slope method, the noise is averaged out by the positive and negative ramps using the process of integration. The basic principle of this method is that the input signal is integrated for a fixed interval of time. And then the same integrator is used to integrate the reference voltage with the reverse slope. Hence, the name given to the technique is dual slope integration technique. The block diagram of dual slope integrating type DVM I have shown in the slide. It consists of 5 blocks: an op-amp used as an integrator, a zero comparator, clock pulse generator, a set of decimal counters, and a block of control logic. When the switch S1 is in position 1, the capacitor C starts charging from 0 level. So the rate of charging is proportional to the input voltage level. The output of the op-amp is given by V out is equal to minus V in T1 divided by R1C, where T1 is equal to time for which capacitor is charged, V in is nothing but input voltage, R1 is nothing but series resistance, C is equal to capacitor in feedback path. After the interval T1, the input voltage is disconnected and a negative voltage minus Vref is connected by throwing the switch S1 in position 2. In this position, the output of the op-amp is given by V out is equal to minus Vref into T2 divided by R1C. Thus, the input voltage is dependent on the time periods T1 and T2 and not on the values of R1 and C. The basic principle of this method is at the start of the measurement, the counter is reset to 0. The output of the, you can see in the diagram, how it is actually the basic principle of this method is actually shown in this slide. At the start of the measurement, the counter is reset to 0. The output of the flip-flop is also 0. This is given to the control logic. This control sends a signal so as to close an electronic switch to position 1 and integration of the input voltage starts. It continues till the time period T1. So as the output of the integrator changes from its 0 value, the zero comparator output changes its state. This provides signal to control logic, which in turn opens the gate and the counting of the clock pulse starts. The counter counts the pulses, and when it reaches to 9999, it generates a carry pulse and all digits go to 0. The flip-flop output gets activated to the logic level 1. This activates the control logic. This sends a signal which changes the switch S1 position from 1 to 2. Thus, minus Vref gets connected to op-amp. As Vref polarity is opposite, the capacitor starts discharging. The integrator output will have constant negative slope as shown in the figure. The output decreases linearly and after the interval T2 attains 0 value when the capacitor C gets fully discharged. At this instant, the output of 0 comparator changes its state. This in turn sends a signal to the control logic. And what happens? The output of this in turn sends a signal to the control logic and the gate gets closed. Thus, gate remains open for the period T1 plus T2. The counting operation stops at this instant. The pulse is counted by the counter, thus have a direct relation with the input voltage. The counts are then transferred to the readout. Let time period of clock oscillator be T, and digital counter has counted the counts N1 and N2 during the period T1 and T2 respectively. Vn will be equal to Vref into N2 by N1. Thus, the unknown voltage measurement is not dependent on the clock frequency, but dependent on the counts measured by the counter. So what are the different advantages of this technique? So what are the different advantages? First one is excellent noise rejection as noise and superimposed AC are averaged out during the process of integration. The RC time constant does not affect the input voltage measurement. The capacitor is connected via an electronic switch. This capacitor is an auto zero capacitor and avoids the effects of offset voltage. The integrator responds to the average value of the input, hence sample and hold circuit is not necessary. The accuracy is high and can be readily varied according to the specific requirements. The only disadvantages of this type DVM is slow speed. That's all about the advantages and only one disadvantages of this